Previously, I spoke about binary and unary operators. So you know that when you add two numbers, like x plus y, this is a binary operator because it requires two things. You have to add two numbers, right? They don't have to both be variables. You could have something like x plus 3. But you need two things or two operands that the operation works on. Okay? We have some unary operators that work on just one value. And two of them are the increment and decrement operator. What they do is add one to whatever value that you specify. For example, here we have the variable x and we gave it the value 1. And then we said x plus plus. This is like saying x equals x plus 1. So we add 1 to the value of x and store it back in x. So now if we try to print this, the output is 2. And we have two variants of this. We could say x plus plus, or we could say plus plus x. In this example, the result is the same, but these are not identical operation. This is called pre-increment, and the other one is called post increment. It makes a difference in a statement like this. Suppose here I have x equals 1, and here I want to add 1 to x and print its value. The result is 2, exactly like before. But if I said instead x plus plus, the result is 1. This is called post increment. So you first use the old value and then you add 1 to it. So if I now have a second statement and I output just the value of x, I got 2. So what this means is after doing this, after this output statement with x plus plus, it's true that the output initially was 1, but the value of x was incremented after it was used in the output. Okay? So you could also use it in an expression. Let's say we have int y equals x plus plus. What do you think the value of y would be? In this case, y will be equal to x. The old value of x will be used in this statement. And then 1 will be added to x. This is how post increment works. So if we try to output the values of x and y, see x equals 2 and y equals 1. But if we did pre-increment, so plus plus x, the meaning of this, it's like giving higher precedence to the add 1 operation. So plus plus x will be done first and then the assignment operation will be performed. Okay? So we first add 1 to x and then store that result also in y. The minus minus, the logic is exactly the same. We have pre-decrement and post-decrement, but they subtract 1 from x. So in this case, the result is 0. But if it's post-decrement, we end up with x equals 0 and y equal 1. So let's trace this example. We have two variables, a and b. We assign 5 to x, so 5 is stored in x. Then we have this expression, 2 plus a. This is pre-decrement. So it means we add 1 first, right? So we're going to change a by adding 1 to it. So a will be equal to 6. And then we have 2 plus 6. So the value 8 will be stored in b. And then we have 2 plus a plus plus. This is post-decrement, so it has lower precedence. We do all the other operations first, and then we add 1 to a. So here we have 2 plus a, so that's 2 plus 6, right? Which equals 8. And then we add 1 to a, so a will be equal to 7. Sometimes we have operations like this. We have a variable and we want to add a value to it. So for example, I want to add 10 to x. So I can say x equals x plus 10. Or I might want to multiply the value of x by 2. So I can say x equals x times 2. Or I can divide the value by 5 or take the mod, whatever. So we're using x in the right hand side in the expression, and then also storing the result back in x. So we can do this using a single compound operator. Instead of saying x equal x plus, we can say x plus equal. These are exactly the same. Here, instead of x equals x times something, we can say x time equal. Here we can say x. All of these operations are valid.